Okay, so now that you've got your circuit built, what we want to do is we want to replicate the same functionality as an analog switch, but we want to use software to do it. So fire up Arduino IDE and let's go program it. Now, if you remember, we have currently got the LED on pin 3 and the switch on pin 2. I will forget that, so we're going to use a macro to code SW for switch and LED for the LED. So that's hash define switch. I'm going to use capital S, capital W for switch, and that's on pin 2. And remember, on macros, we don't put a semicolon at the end. And then the LED is on pin 3, isn't it? So LED 3. Remember what this means. Every time we use SW or LED, it will get replaced at compile time with the number 2 or the number 3. Now, we know that in setup, we need to tell the Uno that we want to use the pins as outputs. Well, now we also want to use an input. So it's exactly the same, but we're going to say pin mode LED. Well, that's the output. So that's exactly as we've been doing in all our other programs. Pin mode switch input. Now, remember, the modes need to be all capital letters, and don't forget your semicolons. And that's our setup done. Now, what do we actually want to happen? Well, we want the LED to come on if we press the button. So we're going to use if statement. Now, we can't just simply say switch. It'd be nice if we could, but we can't. We need to tell the computer, the Arduino, that we actually want to read the pin. And all we want to know is whether it is high or low. So 2 states. So that is a digital read. So we're going to say if, open brackets, digital read of switch. And then we're going to say, well, if that is high, so we're going to use equals high. Remember, we use a single equals if we want to set a value and a double equals if we want to compare a value. And then we're going to open a brace, curly bracket. Well, what do we want to happen? If it's high, we want the LED to be on. So we're going to write digital write LED high. Well, what if it's not high? So we're going to use an else clause, ELSE. And another brace. Well, if the switch isn't high, then we don't want the LED to be high, so we want it to be low. So digital write LED low. And that's it. That's our entire program. Let's just verify it. No errors. Upload it. Uploading. Done uploading. And let's go and have a look and see what's actually happening. And that's not quite what we wanted. You'll notice that the LED is flickering. If I press the button, it's definitely on and it's definitely bright. But it's flickering if it's off. So we've got if it's definitely on, it knows what to do. If it's off, if the switch is off, it's not pressed, we've got this flickering. I'm going to press the reset button, which is this red one up here, just to see if that fixes it. After all, we know turning it off and on again often fixes it. It doesn't fix it here. Have a think about what could be happening, and we'll come back. There's one component we're going to need to add, and that will allow us to fix this. Okay, so you've had a little bit of time to think about it. What we've got so far is a circuit that when you press the button down, you definitely get a high. However, when you let go, you're not getting a definite low. Let's have a quick look at potentially what's going on. So, if you remember, when we are talking about digital electronics, what we're actually detecting is a voltage. And the Arduino is working on 5 volts as being high, 0 volts as being low. So if I was to draw the parallel line for where 5 volts is, just so we can see it. There's our 5 volt line, here's our 0 volt line. Now, what we are hoping to have is something that is 0 volts, and then when we press the switch, it jumps up to 5 volts. So this is the switch press. And we know the 5 volt line is very well defined because we tied it using the red wire all the way to 5 volts. However, what's really happening is when we let go, so when we release the switch, what's really happening is the Arduino is very sensitive and it's picking up electrical noise. Now, sometimes this electrical noise is more than halfway and it thinks it's high and it flashes on. And sometimes it's less than halfway, so it flashes low. What we need is a surefire way to make sure that our value is definitely high or definitely low. And so what we're going to do is we're going to jump back into our circuit diagram, and we're going to see if there's a way we can think of where we can guarantee that this is low 0 volts when the button is not pressed. And so what I'm going to do is I'm going to grab another resistor. This time though, I want a really high value, which is 10 kilo ohms. Brown, black, orange. Hang on. Let's put it in the same one as you. Brown, black, black, red. Depending on whether you're using 5 kilobands or 4 kilobands, the color code changes. But brown, black, black, red is what we're using. And what we're going to do is we're going to place this. I'm going to have to move my switch over one, I think. Yeah. Move my switch over one. I'm going to place it between ground, 0 volts, and our orange wire, which is going through to pin number 2. Now, 10,000 ohms, 10 kilo ohms is very high. So you're going to have very low current flowing through this. Doesn't let current flow easily. So, 5 volts comes to the switch. If the switch is not pressed, this resistor, we say, is going to pull the orange cable, the orange wire, down to 0 volts. So it's called a pull down resistor. if we press the red wire, because this is so high resistance compared to the signal to the Arduino, it's no current's really going to flow that way, and the orange wire will appear high. So by adding one extra resistor, we should be able to fix our problem. So jumping back to our board, here is our circuit that we've already built. We can see that here is our black ground wire, and in my case that's in column 12, and here is my orange signal wire on pin 8, and I simply need a brown, black, red resistor, brown, black, red, which is 10,000 ohms, 10 kilo ohms, and I'm going to plug it between black and orange, between lines 12 and line 8. And as soon as I do that, you can see the LED has gone off. I haven't changed any code. I've just added this pull down resistor. If I press this now, we go high, low, high, low. It's now very definitely measuring high, and it's very definitely measuring low. We're going to use pull down resistors a lot. There is also a version called a pull up resistor that reverses the logic, so that when you press down, you get, instead of getting a high signal at the Arduino, you get a low signal. But we'll come to those at a later date. But for now, build this circuit and see if you can get this to work. And I'll see you when we start doing some counting with this.